Okay, good morning, everybody. My name is Seán Costello, and invited here to chat with you all about robots and I guess industrial automation and control, particularly in the area of biopharmaceutical manufacture. So I have a habit of poor self-discipline. So I do tend to talk and talk and talk. So I'm hoping that Bernard will be a strict disciplinarian in terms of moderation this morning. And if at some point he decides it would be good to interject and allow some time for questions and answers, etc., I rely on him to shut me up and to start that type of an exchange. I guess I do want to give you some sense of my background and give you a sense of what I'll be talking about today, because I understand that you guys could be quite a broad audience with quite a broad backgrounds, and so hopefully what I have to say will have some interest for most of you guys. But for those where I might be either at too high a level or too low a level, my apologies in that sense. But my background is I have a degree in biotechnology, which basically means growing cells to produce something useful. And certainly in Ireland, where I'm based, we're known to grow cells to produce something really useful like beer, Guinness. But where we really make our money is growing cells to produce pharmaceutical type products. So I've spent a good bit of my career in that. But where I did my PhD actually was in the whole area of medical informatics, specifically pathology. And pathology is the study of disease. So usually when you go to a hospital, you don't get to hear or see a pathologist. They tend to be the doctors that are stuck in labs, but they tend to be the ones that look at tissue biopsies and study them under a microscope. And based on what they see, they can make a diagnostic decision. So usually around areas like cancer. And it's actually an area that's really suitable to automation and image analysis. And so I did my PhD in that space right when the internet was taking off, which means that it opened up a whole new field of medicine for remote diagnostics and for the use of image analysis to provide diagnostic decision support for doctors. So I worked in the medical devices field for a good 10, 15 years before reverting back into medicine manufacture, where I spent the last decade or so. And again, in that space, I've been using the skills that I've picked up along the way around automation and control and image analysis in that space. So that's my background. And I'm going to throw up a few slides now and I guess bring you on a journey of what's going on right now in the factory floor in biopharmaceutical plants, with all things software, firmware, hardware type related. So I'm normally somebody who uses Microsoft Teams. So every time I use Zoom, I have to relearn everything. But hopefully I'll get there. So you should be seeing my screen now. So yeah. So the organization I actually work with is an Irish-based company. It's called InnoGlobal. It's been around since 2008. And it focuses on a number of different aspects of medicine manufacture. One really significant aspect is actually people, looking at upskilling and training scientists and engineers to work in all sorts of roles within the biopharmaceutical market. And we do a lot of work in Ireland with respect to that, but also internationally, including in Africa. And I'll talk a bit about that in a few minutes. But another aspect of what we do is where we do a lot of research and innovation with industry around developing next generation digitalization technologies to improve the manufacture of pharmaceutical type products. So the type of stuff that we do typically is on the hardware front, we would develop sensors that might look into a pharmaceutical process and measure something. So it might be a physical attribute, such as moisture content, or the sizes and shapes and colors of particles that form a powder, or it might be a chemical characteristic. So looking at the content uniformity of ingredients in a blend of a medicine manufacturer. So with those sensors, we help pharmaceutical companies who are developing new manufacturing processes. And the great thing about it is that it's all around automation, control, robotics, standardization, so that you can improve the quality of the manufacturing process. Because our sensors measure something, and when they measure something, they generate data. And when they generate data, you need to be able to do something useful with it. So we work with the entire flow of that aspect. So these are just some images of some of the hardware and technology that we use. This one here, for example, looks right into a process. It's actually looking into a window where powders are being fluidized. It's measuring the size and shape of them during the course of the process, where the pharmaceutical company is trying to granulate a powder to a desired particle size range or distribution. So that actually is a robot, because it's an imaging device. It has a light source that needs to be controlled. It has a focus mechanism that's actuated that needs to be controlled. And it has a camera that's taking images. And those images need to be controlled in terms of syncing with the light source, and in terms of those images being analyzed and to do something useful with that data. So here's just some of the image analysis screenshots that we do with respect to that. So very much AI driven, very much using best of breed type of algorithms with respect to that, so like convoluted neural networks, etc. If you're familiar with that type of technology. And here I'm just showing what we do in terms of, you know, at a higher level, holistically on the factory floor, where, you know, we gather data and we move it around for different purposes. So whether it's automation or control or data storage, to provide business insights, etc., with respect to that. I guess if you look in the background there, there's a triangle. And that triangle is intended to show it's a pyramid. It's intended to show a hierarchy. And this is something I'll be talking about later today. Some of you may be familiar with it, but it's about the automation pyramid. That is a standardized way of managing the flow of data within a factory. And it's a standardized way of breaking up on a horizontal level the different functional roles of enterprise systems within a factory. So down at the very bottom, level 0, you have your sensors, you have your actuators that are all part of your manufacturing equipment. And that data flows up with your ground level control. And then you have your supervision control, which involves human machine interfaces. It involves programmable logic controllers. It involves supervisory control systems and distributed control systems. And then above that, again, you have enterprise level 7 systems that manage the data around that. So manufacturing execution systems, laboratory management systems that manage test data and sample data on a product. you have manufacturing operation systems and other business insight dashboards. And then you have what are called your ERP systems, such as SAP, that you might be familiar with, that manage the business drivers of a factory in terms of raw materials in, product out, supply chain forecasting, etc., etc. So that's really how a factory kind of works. And again, I'll be talking a bit more about that as we move on. I guess here's an example of a real life project we're working on at the moment. It's one that's EU funded and involves a number of manufacturing sites across Europe, both in food technology and pharma packaging. And basically, it's very much around developing robot-driven automation on the factory floor. And we in particular are involved in developing an image analysis solution to drive a robot to identify defects in a product and to remove them from a production line. And you can read about that on the URL that's at the bottom of the screen there. I guess some of the stuff we do on the training side that would be applicable with respect to Africa. We run a program called Digiskills Africa. We tend to invite applicants who are from degree to PhD level in science and engineering backgrounds. And basically, we give them a 6-month, very applied, industry-focused program of learning around helping them bridge their knowledge from what they learn in academia to how that's applied on the factory floor and industry in med devices, in pharmaceuticals, in food technology. And it involves a face-to-face workshop as well, which the last 2 occasions we've ran in Cape Town. So yeah, tends to be this year we had about 70 students participating in it. So you can learn more about that on our website as well. I'll kind of keep going now in terms of more about robots on the factory floor and pharma. So this slide needs no introduction, I would say, with you guys in terms of the benefits of what robotization can deliver on a factory floor. So I won't dwell on it, but it does feel like I need to cover it. I guess, examples of what I would see, pretty much most stainless steel process equipment in a pharmaceutical company will have some degree of automation from a robotic point of view. So here's an example of what we call a bioreactor. And it's used to create a sterile environment in which cells can be grown. Usually those cells are producing a protein, and that protein might have a medicinal effect. Might be an antibody, it might be something else that we're looking at for vaccine production or something like that. And so to grow those cells, one needs to manage the environment in which they grow in. You need to prevent contamination. You need to make sure they have enough food. You need to make sure that the waste that the cells are producing as they respire doesn't become a contaminant, etc., etc. So it's a good example of a very highly automated life support system that we would use from that point of view. And equally, in traditional pharmaceuticals, we would have chemical reactors that would do something similar. Another common example here is where we would use pick and place type robots, simply for moving product around, particularly from the packaging point of view, and that's quite common. And quite common from a mass production point of view. And the advantages there, of course, for us, beyond other types of manufacturing is that we can do it with a product that might have very high potency. And so, you don't really want human workers to be coming in contact for their own safety, or indeed the product itself. You don't want that getting contaminated. So you remove or minimize the interaction of humans with the product, because typically the greatest source of contamination in a pharmaceutical plant is via workers. So you try and minimize that. Another kind of key example of where, you know, we get a lot of advantage from robots is from the point of view of dosing and liquid handling. So you can really you know, manage minute quantities with robots in terms of that, and equally do it in a scalable mass produced type manner. So a lot of equipment are focused on that. Even tasks around closing bottles, and again, I would think from a sterility point of view and closing vials, and from a mass production point of view, being able to do that and scale up in a way that drives quality into an operation. So a lot around that aspect. And increasingly, especially with machine vision systems, and especially with more sophisticated artificial intelligence driving vision detection systems, we would look at product inspection. And I guess here I kind of look at a big area where we have vials that would contain, you know, sterile drug product, and how, you know, there's so many different types of packaging involved in that. And even within individual packaging, there's so many different things or quality attributes that one needs to check to ensure that they are correct, and to ensure that there's no impurities that you know, literally could be fatal. So, you know, the big drivers in pharmaceutical manufacturing is efficacy of the medicine you're making. That, by efficacy, I mean that it actually works as intended. Safety of your product, that there's no unintended consequences from the use of your product. And it goes without saying, quality as well is a big part of that. So safety, efficacy, and quality are kind of really three considerations that help drive automation in the industry. I'm going to kind of change gears again here and just talk about, I guess, the generational change that we've seen in terms of that. So really, I'm just going to bring you through, if you're not familiar with it, the concept of industry 1, 2, 3, 4. So industry 1.0 was very much kind of seen around this period, where you literally had cottage industries or rural industries moving to the cities. And in, I guess, the developed world, you know, we tend to think of the Industrial Revolution in Britain with respect to that, and the mass production in cotton mills in cities that sprang up as populations moved from countryside to cities. And I guess what's kind of interesting around that period is the social, economic, political kind of drivers around that. That was a period where, you know, why did it happen in Britain? Why didn't it happen in France or Italy or other places? And as it happens, energy was really cheap in Britain at the time. They had their coal, and labor was very expensive. Believe it or not, at that time, wages were 150 times higher in Britain than they were in Italy. So you had cheap energy, you had high labor costs, and the third key ingredient that Britain had at the time is they had money. They had capital to spend on developing technologies that would automate the workplace. And that's why it really happened in the UK versus in other regions at that point in time. They had the capital at a time when labor was high and energy was cheap. But of course, what happened then over time is that these new technologies became cheaper. And so it suddenly became affordable for other countries to take on some of those industrialized kind of technologies. And so you had a leveling up in the likes of the Italys and the Frances that I talk about that began to happen after about 100 years. And in many ways, it's kind of the story we kind of see today, where you will have an innovator that has the capital and the other economic drivers, such as to develop a new technology. And their leaders, they have this unique advantage, competitive advantage for a period of time. But of course, the price of technology does come down and becomes more accessible to other nations. So you see that all over the world now, where you can actually skip some of the steps to kind of catch up from a competitive point of view. An example of that would be, you look what's going on in India, you look what's going on in parts of Africa, where nobody's going to bring telephone lines now to every single village and every single house. They're not going to bring fiber to every single village or every single house. They're going to just put in mobile technology like 4G, 5G. And so they're going to skip the steps and catch up. And history shows that the precedent is there. So I just wanted to bring one's attention to some of that type of stuff, because those arguments are as relevant today as they were back then. I guess moving on to Industry 2.0, that's very much seen around the mid 1850s onwards, where having had steam now, people actually start looking at how to start automating, and electricity comes in as well with respect to that. And you have an example there, the photo, the famous Henry Ford assembly lines. So I won't particularly dwell on that. And that went on until, I guess, you began to have the post-World War II scenario of transistors, etc., which brought a more sophisticated degree of automation and mass production with respect to that. Or very good. I guess, we've had people starting talking about Industry 4.0, and really that kind of came about. The first publications you see on that would be around 2008, 2009, really out of Germany and the automation industry there, the automotive industry there. And I guess no matter where you look, people have settled on, defining Industry 4 around 9 industry pillars. And I have them listed there. And it's interesting that, over the last 15 years, where those 9 pillars have been out there, I guess they've stood the test of time. And also, they're at a high enough level that some technologies have come along that, underpin what's taking place there. So, for example, artificial intelligence isn't listed as one of the key enabling technologies or pillars in Industry 4.0, but it is there supporting, what's driving cloud adoption, what's driving big data and analytics, what's driving advanced robotics and simulation. So my point is that, there's sub technologies behind these 9 pillars that are kind of driving their relevance in that regard. So that's kind of where Industry 4 is today, and people still see us as being in an Industry 4 type space, and they kind of try and break it down in terms of different stages. So we see definitions around, on the factory floor at least, what we mean by digitization and transformation. So where digitization is literally going from analog to digital. Whereas digitalization then is actually doing something useful with that digitalized data. And transformation is actually changing how you do your business as a consequence of all of that. So useful to be familiar with that. And, people talk about the processes of adopting Industry 4.0 in their businesses. And I guess for a lot of businesses out there, they're still very much at the early stages in terms of digitalization and connectivity, and then actually doing something that with that data from an analytics and a visibility point of view. And I guess as you progress, you get a higher order value out of the digital transformation process around, you know, being able to see your data, being able to understand that data, being able to use that to predict your business, and then to be able to optimize and adapt your business on the back of those predictions. So that's kind of seen as the kind of the ultimate journey with respect to that. I hope we're doing okay. And again, if Bernard, great, I keep going. So to kind of bring that on then to where we are in biopharmaceutical manufacturing, we've taken this generic understanding of Industry 4.0 and the 9 pillars behind that. And we have developed what we call Pharma 4.0, which is really where we're looking at the benefits of adapting Industry 4.0 practices. And so you see 6, I guess, pillars of Pharma 4.0, and they're all basically benefits as opposed to technologies, how they benefit our business. So again, all of those benefits drive product safety, product efficacy, product quality, and certainly we're seeing the impact of that in how we manufacture today. And there is a professional society. It's called the International Society of Pharmaceutical Engineers, and they basically have developed an operating model around this Pharma 4.0, whereby they recognize that it's not all about technology and putting in gadgets, etc. That this is about transforming your business, and it's about every aspect of your business working together. So there's a big part around workforce and communication and culture, because, you know, there's a natural, it's natural for everybody to resist change. It's you know, we all have our comfort zone. So if you want to change your business, you kind of need to bring everybody along. Otherwise, you know, change and digital transformation will fail, cracks will appear. So you do need to take a holistic type approach. And I guess, you know, one of the things that is recognized is you see 2 bars at the very top there. One of them is digital maturity, and the other one is data integrity by design. So digital maturity is that you need to make sure that you understand what your baseline is, what your starting point is. So people will do a digital maturity assessment to benchmark where they are today and understand what their ambition is in 3 years or 5 years. And then they can develop out a plan about how they're actually going to get there. What are the technical steps that they're going to take in their business? What are the transversal steps that they're going to take in their business, and how they're going to resource that? But the other thing, and I go back to this resistance to change, this data integrity by design, you need to trust in the changes that you're making. And to be able to trust in our business, you need to be confident in the data integrity, especially when everything we do is driven by safety and efficacy and quality. So that's where we kind of are there. I'm going to bring in something else that we see from a policy point of view. And this is somebody, I suppose, being really original, decided that, well, if there's an Industry 4.0, it's probably going to be an Industry 5.0 sometime. And why don't I be the first to say it, so I get to own it? So the European Commission, I guess, bet everybody else to it and came up with an Industry 5.0 concept. It's very different to what has happened before, in the sense that it doesn't characterize the next generation of technologies at all. it actually is more of a holistic reflection on, what does Industry 4.0 technologies mean for the workplace and for society? And so they're looking at how this transformation to Industry 4.0 will transform industry, will transform the role of workers in industry, and will, I guess, increase productivity. And so to that end, they've came up with 3 tenets around Industry 5.0. Human centricity, in the sense that, if you want to transform your workplace, you need to bring the workforce along. I mentioned resistance to change. Workforces can be, and society can be, very concerned about workforce displacement as a consequence of bringing in robots. They're very afraid of workforce polarization, where I've the skills to control the robot, so my job's secure, but your job in the warehouse as an operator is not. So it's about bringing everybody along in this collaborative effort, which is what human-centric approach is. The other one is sustainability. So yes, recognition that we have an ecological issue right now with our planet, and a recognition that, sustainability, green manufacturing, circular manufacturing has to drive this digital transformation, both being the incentive and the reward. And then there's also resilience. The idea that over the last decade or so, security of supply of manufacturing goods has been really difficult for everybody, no matter where you live in the world. We've seen shortages during COVID of all sorts of stuff driven by the pandemic. We've seen shortages being driven by natural disasters issues and black swan events, container ships getting stuck in the Suez Canal, etc. So realization that there needs to be greater resilience. And to get resilience means that you have to build in that into your supply chains. So, there's been a mantra for the last few decades around just-in-time manufacturing and lean manufacturing, where you try and thin out your inventory and thin out your resources. And, that system, as we've seen, has broken several times, resulting in shortages. And so we need to relook at that in terms of resilience. And that means adding in cost. So if it's adding in cost, how can you accommodate that? Arguably, the efficiencies and productivity gains you get from automation can help you offset that. That's where those notions are kind of coming from. So it's all kind of tied into that whole type of discussion. So again, these are some of the holistic type of aspects that they're talking about with respect to that, roboticization should be about empowering workers to do higher order value activities, while the robots do the mundane, repetitive type stuff, etc. So worth reading up on in terms of where that narrative is going. Loads of people outside of the EU and peer-reviewed literature have been putting their own take on it. And of course, there's other aspects as well that are driving digital transformation now, whether it's hyperinflation, climate action, energy security, war, etc., energy security. So something bearing in mind. I'm going to change again a bit for a few minutes. And again, you can interject if at any point if you want to move on to a discussion session. But yeah, automation control has been around very much in the modern sense of the word since post-World War II, We've covered, I guess, advantages that I think you're familiar with as well. I guess, you know, there's some restrictions that we need to think about, or limitations that we need to think about, though, with respect to that, in terms of why it's not for everybody. There are high initial costs. There are huge consequences if something goes wrong from an automation point of view. Very quickly, you can have a very expensive volume of product that's defective. And equally, it's not easy to replicate every single process that a human drives. Our brains are actually wonderful and unique and not easy to replicate. And I mentioned the whole worker displacement and the whole polarization as well. So from that point of view, you know, the more you automate, you kind of pick off the low-hanging fruit, and the harder it becomes to gain more and more efficiencies, or the more expensive it does. So very often what you see with factories is they make a choice as to what degree of digitalization or automation or robotization they become. And they're happy with that, because to go any further, quite simply, may not make economic sense or technological sense. So I guess that's the element of it. And the other element too is the so-called paradox or irony of automation, that, you know, the more automated you become, the more crucial the human that's in the middle of it all becomes in terms of driving that. So a lot going on there in terms of societal impact, and I've already mentioned it in terms of worker displacement, worker polarization, and this whole fear that I'm going to lose my jobs to a robot. I guess I would counter that by saying, again, you know, historically, if you look at all of the step changes of industry 1.0, 2.0, 3.0, 4.0, there was always a fear, if you look at the literature and the writing around that time, about worker displacement and people losing their jobs. But actually, what tends to happen is an economy becomes more productive. And because an economy becomes more productive, there's more money in the system. People's standard of living increases. Opportunities for education increases. Opportunities for new forms of employment increases. So I would counter that in the years ahead with Industry 4.0, 5.0, that automation is an economic necessity and it's a societal opportunity in terms of new jobs, extra jobs, careers that have not been invented, etc., etc. But the onus is on us as a society to bring everybody along on that journey. I guess, you know, one term that's thrown around there as well is lights out manufacturing. This idea that you become 100% fully automated and literally you can turn the light out in the factory because there's nobody inside there working. So an example might be data centers, where you can get to that level. And in the semiconductor industry, almost. But by and large, because of the paradox of automation and other things that I've spoken about, it's usually either not technically feasible or not economically feasible to go 100% all the way. So I guess, you know, that's a good thing. People, the more you use robots, the more important people are. I mentioned early on in the first couple of slides around pyramid of automation. So I'm back to that again in terms of that. And it's known as the ISA 95 framework. So if you're not familiar with it, it's worth reading about, because it's basically how factories will lay out their informatics systems. And if you understand ISA 95, then you can walk into pretty much any modern automated factory in the world and have a sense of how they lay out their different enterprise systems and how they talk to each other. So these are their levers here. And again, I'll be sharing these slides if if Bernard wants afterwards. So you'll be able to kind of look at that and read through and how they're organized and how they talk to each other. I guess ISA 95 in that pyramid, it kind of predated the internet. Yes, we've a hand up there, Danny, if you want to jump in. I keep going.
Sorry,
yeah, no,
I was no, keep going. I was just applauding the fact because there's so much information. I'm also having a look at your website, so definitely some work for me to do afterwards. But love the spread. So just keep going. Thanks.
Sure, no problem. And I'm hoping if I endear myself enough to Bernard on this call, sure, he might have me back sometime. You know, you never know. But so yeah, you know, ISA 95 predated the internet, predated industrial Internet of Things, and the whole IoT conversation that's happening right now. So it kind of has to change and adapt. And to that end, it is as a standard. And so there's quite a bit that's out there in terms of communication protocols, particularly industrial communication protocols of how machines talk to each other within a factory, and then how machines can talk to the cloud or talk to the internet as well. There's standards such as the OPC Foundation, that's a big driver of that. I guess there's a convergence at the moment going on with respect to that. And, you know, new standards are being created and adopted. So it's quite a movable feast right now in terms of what's going on. And, you know, equally what's driving it is commercial companies seeing opportunities that, you know, if I can get my standard out there and get it widely adopted, I can kind of own this space. So a lot of moving plates with respect to that. And so to that end, there's a conversation around the pyramid and whether the pyramid needs to change. So you see different types of configurations emerging, such as this unified namespace, a ring type of architecture. So very diverse. And what you also see is the concept of hybrids type structures, that you would maintain your pyramid, but then adjacent to that, you have another architecture. And that would enable and allow, I guess, the existing convention to sit alongside next generation. And that's really useful for an existing factory where they're kind of going, well, we can't throw out everything that we have. It will cost a fortune. So, you know, can we allow, you know, current state to coexist with future state? So this is a way to kind of get there, you know. So yeah, you see a lot of nimble thinking going on there in terms of that. And so, you know, a real kind of driver that I see happening right now is the likes of what's called MQTT, which is a messaging or communications protocol. It stands for message queuing telemetry transfer. And so that is a way for devices and sensors and everything to communicate in a web-enabled IoT type way, but to do so within an industrial environment. So yeah, other things kind of going on there. Obviously, AI is going on there, natural language processing, robotics, predictive analytics. You know, a term that comes up quite frequently now is robotic process automation. Don't know if you're familiar with that. Doesn't necessarily involve any hardware or firmware or cyber physical robots, but really it's about automating a process such as the movement of data, the collection and aggregation of data, the analytical, the analysis of data, and doing something maybe useful with that results of that analysis, such as driving another automated process. So, for example, where you see factories going to electronic dashboarding, where previously they might have had, you know, paper-based charts on a wall that everybody and production teams gathered around, that got updated maybe once a day, once a shift, once a week. Now we have these real-time dashboards, and they can more be driven by RPA, where you have databases being in real time being interrogated, that data being analyzed, and key performance indicators being published to these electronic dashboards that everybody can see and see what's going on. And of course, building those up can be driven by low code, no code type applications. So the likes of Microsoft Power Apps, for example, would be an example of that, where it all of a sudden democratizes a lot of this, where you don't necessarily have to have a programming capability to do some very powerful stuff. And hyper automation is another turn of phrase with respect to our RPA, with respect to that's coming into vogue a bit. One of the things that I look at to keep tracks of this is I look at Gartner top strategic trends. They kind of publish them every year. You get YouTube videos, everything like that, and you actually become familiar with Gartner. Like to come up with a lexicon of trendy technology words. So you keep an eye on what they're coming up with, and you find that those words manifest in your language in 3 or 4 years' time. So, you know, they would have come up with cloud computing, for example, back in the day, you know. I just feel, I know, I hope we don't run out of time, Bernard, but I feel I can't leave today without talking about AI, you know. It is manifest in all of our lives, and I guess the challenge with it is the dangers of it. Dangers of it in terms of how you train AI. You train it using data, and as a scientist, I would say all data is biased. You need to accept that. You just need to understand where that bias sits. Yeah, so just going to give some metrics here. Here's a publication that was published not so long ago, tracking the number of AI-driven medical devices that have been approved by the FDA over the last few years. And this was published mid-2023, and that's the only reason why you see 2023 having a drop. They hadn't gone through the 4 year when they went to press. So I'm sure it's probably double that number, you know. And like the majority of these would be in areas such as radiology, really, and cardiology, in terms of interpreting the radiological images, interpreting, you know, heart traces, that type of thing. So you can really see that that's kind of moving on. And I guess I bring it up because I guess the FDA are very concerned and conscious of, you know, the challenges around AI. They published a paper there recently, and, you know, I outlined the key concerns they came up with there about the potential to amplify errors, concerns around generalizability and ethical consideration, concerns about the explainability and transparency of these black box models, concerns around privacy and security, reproducibility and replicability. So a good read in terms of that, and it's good to see that, you know, policemen like the FDA are been very I guess conservative in terms of the approach. So, for example, no AI-driven medical device has been approved as of yet that's based on generative AI, like ChatGPT type stuff. So it's going to be a while before we see that. And of course, it's got very political. Politicians see the economic opportunity of being a leader in this field. And so everybody's having conferences and congresses and trying to own this space. Governments and countries are trying to own the space as much as companies. And so you have this issue of lawmakers trying to be rule makers. Should we regulate it? Should we regulate it given all the concerns that the likes of the FDA have? Or should we listen to the technologists and the venture people who are saying, no, let's have a Wild West scenario here where, you know, it's winner takes all. So that whole argument is going on, and it's intriguing how it's playing out. And I guess to that end, again, I'm looking at the workplace and who's watching what's happening in the workplace. And, a good place to go is the OECD in terms of that. Equally, I look at what's happening in Europe in terms of policy, and, I look at the Digital Markets Act in particular, and the impact that could have. People think it's all about, consumers, and such as you and I, who use web browsers, who use, Gmail or Outlook, and about the monopoly that big companies have on it, whether it's Facebook or Meta or what have you. And yes, it is about trying to ensure that the monopoly that these large companies have isn't misused by manipulating you with disinformation and biases and everything for harmful purposes. But actually, it does extend into manufacturing as well. So, under that act, they do name individual companies and technologies that are obliged to meet a higher level of regulatory practices in order to dissuade them from manipulative acts that are harmful to the consumer. Where that fits on the manufacturing side is really here. It's a recognition that, if the last 20 years has been about personal data, because, me using Facebook is free. And if it's free for me, then, a lot of people say, then that's because I'm the product. My data is the product. But there's a recognition that if it was all about personal data in the past, it can equally in the future be all about manufacturing data being the product of the future. So, pharmaceutical companies are concerned that if they buy a next generation packaging machine or a next generation bioreactor, that the pharmaceutical company's proprietary data suddenly becomes the proprietary data of the equipment that they use to make their medicine. So that kind of tug of war is kind of beginning to emerge. As is, what's said in the last there by a quote from Siemens, that they're concerned if they're regulated and they cannot lock down this data, that it makes it easier for competitors to retro-engineer their innovation. So a lot of interesting debates going on there into technology, robotics kind of field. So yeah, I'm going to finish up and say I can't finish this without talking about cybersecurity. It's very important in the industrial side of things. There's constant assaults and attacks. You can monitor various sites that kind of give warnings around attacks on industrial automated systems. There's plenty of predicates out there of where medical device and pharmaceutical companies have been hit. It's real business risk. And so it's something that pharma companies and manufacturing companies, take into account. And it's actually one of the reasons why the ISA 95 framework is great, because you can segregate out all of the horizontal layers, and you can control and basically firewall individual layers within it in a relative way. That's protecting against cyber attack. Okay, I'll stop now. Sorry about that. And thank you to everybody who patiently endured it. I know there was a lot there.
Seán, no need to apologize. That's been phenomenal. If anyone wants to come in with a question, I'll give you a chance in a minute. I just want to say, first of all, the breadth and depth of information you provided us is just incredible. I see Danny shaking his head in agreement there. And yes, it's something that we need to go back over ourselves. Secondly, just to give you an insight, we have I've seen on and off the call this morning, we've had Nigeria, Sao Tome, South Africa, Tanzania, Zimbabwe, Uganda, Kenya, France, Ireland represented here. So you've had a Pan-African audience as well as some European. I think you kind of summarized something which is really important here. You said the more we use robots, the more important humans are. And that shows actually how important the mission of the WHO is, that the next generation of young people need at a very young age to have that understanding. And everyone who's been on this call this morning is involved in that process. So I think that it kind of almost inspires us to realize, yes, it's more important than we may have even realized when you think of exactly what you've said there. And you repeated that twice in a couple of different ways. As I said again, actually, I'll be coming back in from Nigeria. So, and I think as well, even just the Gartner terminology is very helpful for all of us to even know. Outside of everything else, there are just a couple of things. Is there any questions from anyone here? I think a few people have left because they've probably gone on to their next call at this stage. Anyone to have any question or say anything?
Yeah, Bernard, if I can just
Sure.
thank you very much, Sean. Yeah, very interesting and way beyond sort of us foot soldiers and educators, you know, trying to bring this to the masses of young children, certainly in Africa, because you know, the reach isn't always there. I have a question relating to, and it's purely out of interest, is you know, the spread. So, for example, with the movement through the industrial revolutions, for example, you know, I'm not sure when 4.0 started. I think you said, I just looked at the slide saying that 3.0 until 2012, for example, you know, it was a question mark there because there's no definitive date. But when you know, when one moves from, for example, 3.0 to 4.0, and 4.0, let's say that is now approximately 12, 14 years, the spread of the competence within countries and the planet who advance with it and those that lag. You know, I mean, do you guys have any sort of impressions, or is it seen somewhere? Do you try and measure it along there? Because obviously that does happen, you know. So the countries that won't even have finished 3.0 yet, and here we're talking 5.0 and what it entails. So just a little your view on it.
Yeah, so I guess yeah, to your point, there isn't a you know, a definitive line in the sand of when the world goes from 3.0 to 4.0 or whatever. I would take as a marker that the Germans lay claim to Industry 4.0 simply that from the point of view that government policy publications emerged around 2008, 2009, where they started calling what they wanted to do Industry 4.0. So that's the only reason I put a time marker there. And certainly, I think Industry 1.0 to 4.0 is a human manufactured concept anyway. We're always in a continuum of progression and advancement. What I would say is that, and we're witnessing it ourselves, what the experts would tell you is that change, the rate of change is accelerating. We can both see that in our lifetimes. You know, things are moving faster than they were in our grandparents' time, without a doubt. I think though as well, you know, I made the point about how just because you're not at the bleeding edge of where things are happening doesn't mean that you're going to be left behind. I gave the analogy of how, you know, if you don't have, you know, fiber to your house or to your village these days, you're probably not going to put the money into laying it now anyway. You're just going to, you know, get a 5G or a 6G mast, you know, and have a more than acceptable experience. So you can skip, but equally that means in terms of skills, you know. So you go back 10, 15 years ago, and to be an industrial automation engineer, you really did need to have advanced electrical, electronic, and programming capabilities. Whereas as technologies have become more accessible or advanced, they become more accessible to a broader part of the population. For example, one of the big drivers right now that's driving the adoption of AI is that you don't need a PhD in advanced mathematics to understand convoluted neural networks or random forest type classifiers or stuff, mathematical concepts. What you can do is, much like the Scratch experience, access technologies that are being made available via Microsoft Azure, via Google, via Amazon, via Meta, which allow you to build AI processing units with a fairly quick learning curve that, as I say, you don't need to have deep understanding of how it works. You just need to know how to use it. I think that this is what I mean about the democratization of, I guess, technologies as we advance. And so I wouldn't be fearful at all if you are working in an educational system or a nation state where it's not Silicon Valley. You can't hold back the tide here. The tide is going to be accessible to everybody. And I think, the fundamental skills and concepts that you're providing through your program, are just excellent in sufficiently demystifying this whole space in a way that people, when they become mature enough, can, via self-directed learning, be whatever they want to be and do whatever they want to do. You're giving them enough information to be dangerous. That's what I would say.
Yeah, thanks. I mean, I like the idea of, sometimes, you're trying to teach and educate, et cetera. And sometimes it's just actually advantageous or beneficial to have leapfrogged a certain section because you didn't require all that knowledge anyway, and we just keep preparing like that. So as you say, it's the holistic approach in the development of our youth. Thanks, man.
Yeah.
And also, Seán, just on that, thank you, Seán. I'll bring Eva in. She has a question. I like your description of what is happening in WRO was sufficiently demystifying to be able to become dangerous. I will quote.
Yeah.
Yeah, my question, part of my question was addressed by Danny, so I don't have question anymore. Thank you.
Good.
I think the crucial thing is you don't have to be in Silicon Valley to be up to date. Abby, you have your hand up. You want to come in there, please? And Abby's coming from Nigeria.
Hi, good morning, everyone.
Morning.
Yes, thank you very much for this, Seán. You really took me back to class in Oxford. Excellent. I was like, oh, I don't need to do a master's in digitalization, and you've done that this morning. I wanted to ask about Digiskills Africa. What's the opportunity around that for people like us in Nigeria to upskill? We have so many people looking for such opportunities, but there are very few and far-fetched. How can we tap into this? What's InnoGlobal's plan for expansion into areas such as that? Thank you.
Okay, no problem at all. And I'm delighted that somebody wanted to compare me to Oxford, that's a step up. But I guess with the Digiskills Africa program is something that we have done as a proof of concept program over the last 2.5 years. and we've done 2 instances of it. And we've worked with a number of governments to do it. So we got some support from our own government here in Ireland, and support from Kenya, Botswana, South African governments as well, and Ghana. But it is open to everybody from all of the African nation states. And what we were trying to do is establish a precedent that yes, we can run a program like this. We can run it over 6 months. We can run it as a hybrid of online and in person. And there is an impact, a measurable impact. So what we do is that for those who have been on the program, we track their progress subsequently and work with them subsequently with a view to supporting their career goals. So it has been partly funded by ourselves and partly funded by the Irish government to date. And at the moment, we are trying to get a funding model in place to allow us to expand it further. The idea being that, rather than, we ran it with 30 students the first time, 70 students the second time. We'd like to exponentially grow that again. And we'd like to be running it in person in a number of different regions. It's just really trying to find a sustainable mechanism that allows us to achieve that. But what we're left in no doubt to date is that it has a consequential impact on those who undertake it. A big part of what we do is applied skills, absolutely. But I think the most understated part of what we do in that program is transversal skills around CV preparation, interview preparation, around how people try and progress their careers, and to develop them that way whereby they can properly expose all of their skills, all of their qualifications, all of their experiences and competencies. Because most people are understated, and they don't sell themselves as well as they could, and for us it's about really trying to drive that.
Thank you.
Thanks, Abby. Thanks, Sean. Did I see Valentine with a question earlier? Or perhaps she's on the mindset quarters. Perhaps she hasn't. Okay. Anybody else want to come in? Right. So Sean, thank you. That has been superb. Yes, we'd love to follow on in a while. I think we need to reflect, obviously, and look at what you've been talking about, because it's, as we mentioned, it's so broad, but it's also very relatable. Oh, sorry. Valentine, do you want to put the question in the chat and I can ask it, because she's saying she can't mute? Yeah, I think she's
Yeah.
Yeah, it's so relatable, and exactly some of the things you've said there about how important the work is. Then I think that, as I said, gives us all a boost to know that we're not working in a vacuum here. And
No.
exactly like you said, you don't have to be in Silicon Valley to make these impressions. And I know Danny, from years of experience of being a head judge at the WRO, understands that, and how impactful people can be from every country. And this is why we have like our Sotoma here on the hopefully heading to Turkey, and we have a representative from across Africa. So thank you so much on all our behalf. Thank you for your time and the work that went into that. I see here, sorry, yeah, Valentine just saying no questions, appreciating the, sorry. just doesn't come up for me.
Presentation.
Appreciating the presentation, very informative. So thank you for the help there, Manuela. And yes, thank you so much, because the amount of work that went into putting all that together, your time and even your interest in the call we had last week, really enjoyed it. And also, I think everyone here has, and we see some emojis here coming up about how good it's been. So thanks yourself, and you can go back, and I'll be telling Ian you'll be compared to Oxford University lecturers. So
That'd be great. That'd be great indeed. Yeah, thanks again for that. I mean, but like, look, if there's I covered way too much. I know it's like drinking out of a fire hose, but if there is specific niche areas that you would like to delve deeper, you can always get me back. Yeah,
definitely. I will definitely have a conversation and come back to Sean. Thanks so much. Thanks to everyone for joining us and for all your time as well. We really appreciate it, and it's great. And we'll be sending out this recording to everyone else and expanding it across the network.
All right. Bye, everyone. Bye-bye.
Thank you, Sean. Thanks, Bernard.
Bye, everyone.
Bye. Bye, Manuel.